A very good afternoon to all. I'm warm welcome to all the students in my lecture 3 of module 3 or module 6, sorry, module 6, that is a rapid prototyping. Here I am going to start the third type of the rapid prototyping. Okay, that is a laminated object manufacturing. This is also called the LOM. In this technique, the layer of adhesive coated sheet material bonded together to form a prototype. The original material consists of a paper laminated with the heat activated glue. In this case, we are for the bonding purpose we are using the glue and rolled up on the spools. There is a feeder and collector mechanism advances the sheet over the build platform where the base has been constructed from the paper and double-sided form type. In this In the next stage, the heated roller applies the pressure to bond the paper to base. A focus laser cut the outline of the first layer, means the focus laser always cut the material as per the requirement, first layer into the paper and then cross hatches the excess area. Cross hatching breaks up the extra material, making it easier to remove during the post processing. During the build, and the excess material provide the excellent support for the overhang and thin walled section. After the first layer is cut, the platform lower out of the way and fresh material is advances or fresh material is advanced. The platform rises slightly below, means going slightly below and the previous height, means as per the thickness of the material. The roller bonds the second layer to the first and the laser cut the second layer, and this process is repeated as needed to build the part, means till the last stage it will be the process is repeated, which will have the wood like texture. Because the model are made of paper, they must be sealed and finished with the paint or vanish to prevent the moisture damage. So this is like the description regarding the LOM. In the next slide, we will see the diagram or schematic diagram so that understand the different types of component as well as the different types of what are the process actually. See, this is the schematic diagram. In this case, laser, you can see over here the laser, and here also we are having two types of mirror. One is called the mirror, otherwise called the dancing optic head. Okay, here we are having the feeder, though it is feeded the material. Here we are having the collector. Okay, and this is called the heater bar, and this is below you can see this is called the platform. Okay, initially the platform at the zero position, zero datum. Okay, first the feeder provide the advancement of the sheet, and the sheet will be here. Okay, sheet will be here. Once the laser cut the sheet as per the requirement, this glow or heater roller will be moved here to here and fix the one material to another material, and this goes platform goes down as per the thickness of the feeder, and this process will be repeated until the whole model as well as the whole model or product has been ready or prepared. So this is like a process. By this method we can form a different types of model in the laminated object manufacturing process. What are the different types of application range? First application range, it is used in the conceptual design. Okay, it is used in the area of conceptual design. Second, it is used in the sand casting pattern as well as the large bulky model. Okay, in different large bulky models we can use the LOM. Advantages: various organic and inorganic material can be used, such as the paper, plastic, ceramic, and composite material we can use in case of a LOM. Okay, wherever we required. Normally you have seen different types of the boxes are there for the packing purpose, which is made by the paper. Okay, this is made by the LOM. Relatively low cost compared to the other method, much faster process than competitive techniques, virtually produces no internal stresses. There is no internal stresses associated with the and associated undesirable deformation. Robust capacity of dealing with the imperfect STL file. Sometimes the perfect STL file is not perfect. That time we can use this method, and this robust capacity of dealing with this. Best suited for the building large part. Okay, this is a method because layer by layer it is formed like a building block material we can also form by use of LOM. It has a little disadvantages. First disadvantage, due to the bonding we have done by use of glue. Okay, there is a one plate, one sheet will be there, another sheet will be stick together by using glue, but that bonding is not that much good, as the strength of that bonding is not good. Okay, so maybe sometime it is open. Okay, the strength of the material is not good. In the Z direction it is not possible to do the manufacturing. Hollow parts like the bottle it is not possible to make it. This is the disadvantages. I am having the small video regarding this. This video downloaded from the YouTube, and it is not used for the commercial purpose. It is only for the free education purpose or education purpose I am using over here. Okay, you can see this video only for the understanding what do you mean by the layer laminated manufacturing or LOM. Okay. You can see over here, this is called the feeder, this is called the collector. Okay, the material will be advances from here to here, and you have seen this is a laser. Okay, laser light. Okay, this laser light always will moving on this material, so that the material it will be cut as we required the model, and it is a platform which is always going down as the thickness of the material. So you have seen this material, okay, how we can perform the LOM. This video is available here. And next method is here, that is called the fusion deposition modeling, that is also called the FDM. Okay, and this is the fusion deposition modeling machine is basically as a CNC control robot carrying the miniature extrude head, that is called the nozzle. This is called the extrude head. You can see over here. This is called the extrude head. Okay, consists of a nozzle also. By feeding the head with the plastic wire, solid objects are built string by string. In this technique, the filament of the head heated thermoplastic are extruded from the tip at the mouth in the XY plane. Okay, this is the material which is our here. It is a feeder. It is continuously fed into the this extruded head, and it melted inside, and temperature goes down little, and after that by using this two roller it will be moving outward direction, and immediately it forms this some model layer, and after that it cooled and to form the final object. Okay, the control extrusion had deposited very thin bits of a material into the build platform to form the first layer. The platform is maintained at the lower temperature so that the thermoplastic quickly hardened. After the platform lowers, the extrusion had deposited the second layer upon the first, and this process is repeated till we got the final model. You can see over here also the same thing. We are using the ABS and the another other material also for performing this kind of operation. What are the advantages and the application? The first application, it is used in conceptual design, it is used in functional application, manufacturing procedure, it is used in investment casting and injection molding. This is like a application and the range of the FDM. Advantage is quick and cheap generation of a model, easy and convenient date building, no worry of possible exposure to toxic chemicals, lasers or liquid, because in this case we are not using the CO2 and any kind of laser. It is just having a nozzle. That nozzle head will be responsible to or enabled to make the final product. No wastage of material during or after producing the model. No requirement of a cleanup, because no base as well as any kind of a base required. Quick change of material. Okay, disadvantage, restricted accuracy due to the shape of material. Use wire of 1.27 mm diameter. Only that is the disadvantages, but that is not the major disadvantages. Okay, we are having a few example also in our college. Also we are having a one uh, model that is made by our student or fabricated by our student in the last year as a project. Okay, you can see this video, so your concept is more clear. See how this nozzle head is here. This nozzle head makes you can see how this some parts in the example I am putting forward. This is the analysis of this model. Okay, now this is the platform. In this case always we keep some temperature to the platform, but the temperature of the platform is always lower than temperature of the head, because the temperature of the head is always having the temperature of 210 centigrade to 10 degree or degree centigrade, but the platform having the temperature of only 60 degree or 80 degree we can say, but without heating to that level it will not, the operation will not be start. Okay, so this is the platform always having the some temperature. Another video I am having over here, you can see a little.
Fused deposition modeling, or FDM, is a layer additive manufacturing process that uses production-grade thermoplastic materials to produce both prototype and end-use parts. This technology is known to accurately produce feature details and has an excellent strength-to-weight ratio. FDM is ideal for concept models, functional prototypes, manufacturing aids, and low-volume end-use parts. The FDM process begins by slicing 3D CAD data into layers. The data is then transferred to a machine, which constructs the part layer by layer upon a build platform. Thin thread-like spools of thermoplastic and support material are used to create each cross-section of the part. Similar to a hot melt glue gun, uncoiled material is slowly extruded through dual heated nozzles. The extrusion
This is the nozzle, okay, and if I'll go a little back,
similar to a hot melt glue gun.
this is the two nozzle, okay, means whenever we want that object or the model in the different colors, so we can give two different colors, okay, by the two nozzle also. This is called the feeder also, and this roller always feed this material to the particular nozzle, this position, okay. And here the temperature is around 2 to 10 200 to 300 degree temperature, so that this material is little melted over here, and according to that we can make the some object.
Uncoiled material is slowly extruded through dual heated nozzles. The extrusion nozzles precisely lay down both support and thermoplastic material upon the preceding layers. The extrusion nozzle continues to move in a horizontal XY plane while the build platform moves down, building the part layer by layer. The finished part is removed from the build platform and cleaned of its support material. Raw FDM parts have visible layer lines. However, service providers such as Solid Concepts offer multiple finishing options to create smooth, even surface parts including hand sanding, assembly, and cosmetic paint. Since FDM parts are constructed with production-grade thermoplastics, including ABS, polycarbonate, and Ultem, they are both functional and durable. FDM is utilized in a number of industries, including aerospace, automotive, industrial, commercial, and medical.
I hope you all understood what do you mean by the FDM by these two videos, okay. And now I'm going to conclude my lecture over here with these videos. And the next type is 3D printer, but 3D printer is also the example of the FDM. They are using the same processes, okay. So no need to show that FDM also, but you have to remember that the FDM as well as the 3D printer both are same. Thank you very much for your great patience to listen me. Okay, thank you very much.